In this section, we're going to talk about something called the preprocessor, which is going to be a bit of a new idea for some of you. So in general, when we go to compile something, we basically think to ourselves, oh, whatever I wrote, well, that's what's going to go into the compiler, and that'll be compared to machine code, and that's what will end up being executed. So that's fine, right? It works just like that in Java. But in C/C++, we have a little bit more flexibility from this thing called the preprocessor. The basic idea is this. Prior to your program actually being compiled, there's going to be an additional step where your program is maybe fixed up or edited slightly before it's being fed to the actual compiler. On this slide, I have an outline of the basic compilation process in C. So let's take a look on the right-hand side. So on the top, you'll see we have source code, right? That's what we write. But then there's something after it called processed code, right? And so this is the thing that's new in C, right? There's actually a step where that text source code that we've written, it's going to be transformed in a sense. We're going to add a little kind of notation within it that says essentially to the preprocessor, oh, do this or do that to rewrite my source code in a certain way. The result of that is what I'm labeling here as processed code. It's been cleaned up or altered just a little bit. And then from there, the other steps are maybe a little bit more familiar. So once we have kind of our code processed by the preprocessor, we're going to generate some assembly for it. After we have the assembly, then maybe we can look at generating machine code. From the machine code, we can get an executable. What's of interest to us, though, is just this extra pre-processing step, right? This thing right here. So let's take a look at what we mean by pre-processing. Now, go ahead and just jump down to the bottom here, and let's take a look at the example real quick. This code has kind of a new feature that you haven't seen before. There's this symbol here, pound, followed by the word define. There's actually a bunch of different words that can come after that pound symbol. The pound symbol is to indicate to our language, to our compiler, that you have some sort of command for the preprocessor, or more specifically, a preprocessor directive. So what is this line here doing? Right? We'll talk through this. Basically what this is saying is, oh, hey, define a symbol. Right? This is over here as a symbol, right? You don't want to really think of it as being like a variable or something, but it's a name that's going to have some value bound to it, right? Throughout our program, we'll be able to talk about the symbol maxval, and then later on, actually when this preprocessor runs, the purpose of it is to actually go and look for kind of references to maxval and say, okay, they need this symbol here that was defined to have the value 100. So every time I see that symbol in my program, I can rewrite it. I can take out maxval and I can put 100 there. In that sense, maybe you can use the preprocessor like something that defines constants. Although that's not really kind of the full power of it, but it's certainly something we can do, right? We can bind a value to a name. So overall, kind of one of the big purposes of the preprocessor is to provide this kind of substitution functionality, right? We're replacing a name by something else. We can actually do things more complicated than just a value and a number. We can actually define things that look a little bit like a function. So over here, right, we have something to find the roots of a quadratic equation, quad fn. And notice here, right, that we have actually our familiar little parentheses, right, to indicate that there are maybe some arguments going to this thing, right, a and b. And then on the right-hand side, we have kind of our full formula, right? This is our actual expression that we would use to calculate out that result. And again, this is something that the preprocessor, right, is going to look through your file, right? First of all, it kind of discovers, right, that, oh, quad fn is another kind of symbol that's been defined. And then, right, as it keeps on looking, it'll look for instances of the word quad fn and replace them by whatever we have told it to replace it by, right? So we've defined this expression should replace this name with a and b. And so then you can see that down here, right? Our kind of example code here is saying, oh, we have kind of our defines, right? Those are actually going to be part of our program. And then we have this line here, right? X equal maxval plus quad fn, and then it's getting some parameters, right? 5 and 16. But after the preprocessor runs, it's actually going to kind of throw out those defines. It's going to basically make a note, oh, these are the replacements I need to do. And then it's going to do those replacements, right? So that last line there, you'll notice that, for example, maxval is no longer the word maxval, it's the number 100, right? There's been a substitution that's taken place. And then over there for quad fn, the same thing has happened again, right? That expression that's bound to quad fn has been essentially copied down below, right? And then that 5 and the 16 have been substituted in for a and b in order to give kind of that expression that has everything all together. Now you might be wondering, what exactly is the point of doing this quad fn thing versus just doing like a function? Well, actually, right, this isn't a function in any sense, right? This is literally rewritten our program code in order to inline that expression, right? That a square root b, blah, blah, blah. We're inlining that, right? So there's no kind of overhead for us to call a function or anything like that. It's just emitting pure code. Okay, and so I guess the last remark here, right, is that all this is happening, right, this conversion step, right, where we go from this stuff up here, right? This is happening long before our compiler ever sees the code, right? The preprocessor runs, takes this stuff in, and then generates this stuff. and only then does it actually get fed to our compiler. And then, compilation happens, and we actually get something that we can run. Okay, so let's take a look at using the preprocessor to define things versus just a function. You'll also notice there's kind of the term at the top of the slide, macros. That's maybe another name you'll hear, right? People say, oh, I've defined a macro to do this or that, right? To, represent this expression or have this value. So let's take a look at how these things kind of differ, right? The preprocessor versus just using a function. So in this first example, right, we have this very simple program. Basically, there's a function up top that calculates absolute value, and then we have a main down there, which creates a variable, sets it to a value, takes the absolute value of it, and then prints it out afterwards. So this is kind of a pretty simple program, right? We can maybe trace this real quick, right? We can say, okay, initially I is going to be 3. Okay, that's fine. Then j is going to be equal to something based on ABS, right? ABS is a function we're calling. And here, right, you'll notice we have the pre-increment before I. So basically we're saying, oh, on the number 3, I'm going to increment it to 4 and then pass that 4 to ABS. And then instead of ABS, maybe I'll write in here my number 4 here. Over here, right, ABS gets 4 coming in. And 4, right, 4 fortunately is a positive value, so we don't need to do anything. We basically just jump over here to the other branch and return the value, right? This is kind of the true branch over here and the false branch, right? If you remember, this is the kind of short form of the if statement. Conditionals over here, question mark, then kind of what you should do if it's true, colon, what you should do if it's false. So in this case, right, our value is positive, right? So there's nothing for our ABS to do. So we jump directly to the false branch, and the false branch says, oh, you just return A, right? So in the end, right, we end up just returning the number 4. So over here, right, J is going to be equal to 4. And then we print out the number 4. So that's fine. Let's jump to using a macro, right? And we already talked about this kind of idea, right, is that using the preprocessor, right, to inline these expressions, right, is maybe a little bit faster than using a function. But there's also a side effect. Literally a side effect. So I could trace through this again, but the kind of the output, right, is already shown on the slide. So I can just I'll just circle this for a second, right? So this program is basically the same, but what I've done is I said, okay, I'm going to use that define keyword, right, to create that ABS instead of using an actual function. And everything inside, right, is kind of the same, right? We still have that same short form if. But the result that we get from this is the number 5. We don't get back to number 4, right? So even though we're trying to implement that same thing, right, the ABS, it doesn't work. We get back a different value, which is not something we want, right? I mean, we traced this manually on the previous slide, and it seemed pretty legitimate, right, for this thing to return 4, right? I mean, we give 4 to ABS. ABS shouldn't change that. So there is kind of a little issue here with using this. When the preprocessor runs, basically it's going to go through, right, and copy paste, right, a rubber stamp all of these little things it knows about directly into your code, right? So it's going to do this replacement, and it does it kind of blindly. So what that means is that over here, this line ABS ++ I, in the end, that will actually be turned into this. Parenthesis, parenthesis, this is A, right? And so I'm actually going to write in that parameter, right? The parameter looks like ++ I, and so that's going to be essentially put in wherever A goes in that expression. Less than 0, question mark, -1, times, and again I'm going to do a ++ I, colon, ++ I. And I guess, well, we should probably put the semicolon at the end and kind of X out this stuff here. This is the expression we get. So if we look at this and try to trace it now, what we realize is the following. 3 is initially the value of I, right? Fine. Over here then, our condition, right, when we're trying to, assign something to J, right? J is equal to this stuff, right? Well, we got to figure out what this stuff is. That value of I, right, is initially 3, and then we do write ++ I, so we're actually comparing there is 4 less than 0. Right, is the conditional that's going to happen. So that ends up being false, right? So we need to jump over to the false branch over here. But then this branch over here has ++ I again. But I, right, I is already updated from the first time we did a comparison, right? It's the value of 4 now, right? That ++ changes what I is. And so over here, this actually becomes essentially ++ 4 or 5, right? So then the value 5 is assigned to J. Right? There's been kind of a side effect, right, is that when we copy and pasted ABS from its definition into our program, basically we duplicated that ++ thing. So now it occurred in 2 places, and so we got 2 increments instead of 1, which is definitely not what we wanted. So this is kind of a general thing to be concerned about with using macros, is that you have this kind of potential for these side effects, right? Something unexpected to happen whenever you use them. On kind of a good note, though, some compilers will actually protect against this. And then, of course, some won't, right? So depending whether you run this on, say, Visual Studio or GCC, you'll actually get either 4 or 5. I mean, ideally, everything should be the same everywhere, but it's not because macros can be a little bit annoying. As kind of a side note, there's also something called inline functions, which kind of can bridge the gap between using a macro and using just a function, right? An inline function is basically a function that the compiler will, smartly inline, right? It's not going to copy-paste everything. It's going to actually go and kind of make sure that things stay the way they're supposed to be. Okay, so there are actually a bunch of different directives we can send to the preprocessor in order to do different things. So far, we've just seen define, right? And define basically used it to create this symbol, right, that's maybe bound to a value or maybe bound to expression, right, to create these little macros. Now, there are a bunch of other things you can do. So on this slide, I have a bunch of different directives that you might see in the wild, so to speak. So over here on the left, I have this stuff, pound include. Basically, this is a directive that says to the preprocessor, I need to bring in a bunch of source code from another file. For example, the top line is saying, bring in source code from standard.io.h, or the next one is string.h, right? Bring in whatever's in there, right? And literally that's a copy-paste operation. So all the source code that's in one of those files will be brought over and be copied into the place where there's currently an include. So this is kind of very common and very useful, because this is actually going to be a way that when we're writing our programs, right, we can bring in source code from other places and then leverage it, right? So if we want to have string manipulation abilities, we do our include string.h, right, in order to get stuff like string copy or whatever we need. So kind of an additional note here, right, is you'll notice that there are these arrows. These arrows are actually saying something. They mean that this library I'm pulling in came with a compiler. It's something that's built in. But then over here, right, you'll notice we have the double quote. The double quote actually means, oh, this stuff is coming from a local project, right? Maybe it's a file that I wrote and I want to bring in my file, right? So double quote says look locally versus the arrows mean, oh, it's part of the compiler installation, right? It's a default thing. So you'll see both. And these are almost always right occur at the top of your file because you kind of need to define everything you can work with right before you work with it. So typically they're at the top. The other one here is listed, right, is this pound and pragma. Basically, this is specific to Visual Studio. I wouldn't worry about it too much, but you'll see it kind of in some of our examples, right? This pragma warning disable 4996. Basically, what that is a way to suppress some error messages that Visual Studio likes to show us whenever we use kind of an older style of C. It's just a Visual Studio thing, though. If you're another compiler, you really don't have to worry about it. So in the middle, I have an example of what is called a header guard. This is actually code you might see in something called a header file or a .h file, right? A file that kind of tells you about some stuff that's out there, right? Maybe provide some functionality that other files need to kind of reuse. So let's just read this top to bottom. So the first thing I have, right, is if not defined, right? So this is actually a little bit of logic going on in here, right? So that I have the ability basically to say, oh, if something is like this, then do this. Otherwise, do something else, right? We have some logic. So what this is checking is to see whether this utilities_h symbol has been defined, right? If it hasn't been defined, then we're good to go. Then we can actually go inside and do the stuff in the if statement or the if clause. So let's say it's not defined. What happens? Well, then that second line will run, right? Define utilities_h. So basically we're saying, oh, I didn't have it, so I'm going to go ahead and bring it into existence, right? I'm going to define that symbol. And then we kind of go down, so we do an include, so we bring in standard io.h, okay, go down again. Then we have a forward declaration for something called flush, which must be a function that's defined somewhere. And then maybe we have a bunch of other lines. And at the very end, right, we have this end if, right? So we kind of have to end out that condition that we checked, right? We checked to see if something was not defined, it did a bunch of stuff, and then we kind of got to the end, right? We say, okay, end if, I'm at the end, I don't have anything else to do. All right, so we're doing an end if for that utilities_h symbol, right? We couldn't find it, so we did the stuff inside. So this is actually kind of very typical code, you'll see. The basic kind of motivation for it is that, okay, I'm going to have some files in my project, right, that maybe I need to use in a couple different places, right? So maybe I have a header file, right, this .h file, and I include it in a couple of my source files. Well, every time I go to compile each of those files, it'll try to compile that header as well, and that's a little bit redundant. So what we want to do actually is force the compiler only to compile those headers just one time. And so that's actually what this code here we're doing is actually meant to perform, right? So it's meant to say, okay, I haven't been compiled yet, right? That symbol hasn't been defined. So go do everything inside and then end out, right? And then later on, if the compiler goes to compile it again, well, that utilities.h symbol is already defined, so it's going to skip out, right? It's not going to do anything. So this is a way, right? We call it a header guard to prevent the compiler from compiling a header more than one time. It's going to save time, and it's also going to prevent some very, very strange bugs. So the last thing I have here over here on the right is kind of an extended example on the stuff we just talked about. So over here, right, we have if-def. If-def, right, is just checking to see whether a symbol exists, right? Has this macro been defined? So has Win32 been defined? So you might be able to guess this, but conveniently enough, on all the different operating systems, there's typically some symbol that'll be defined automatically to show what operating system is running. So if we're on Windows, usually we can count on _Win32 being defined already. Or if we're on, say, Mac, we might see OS X being defined already. So we can actually do this kind of if logic, right? And based on the platform we're being compiled on, do a certain thing. So over there, right, if we're on Windows, we include Windows.h. If we're over on Mac OS, then maybe we just print an error message and tell the person that they should maybe just buy a real computer. Just saying. So else, right, those two things don't work out, then we include something else, right? Maybe we include the standard libraries for Linux or something, right? So we have kind of these symbols that are already defined, and we can do logic based on them. Let's take a look at a few more of those predefined symbols. So we already use, right, that if-def, right, to check to see what platform we're on. There's a few other symbols that basically you can use them to maybe debug or to help understand how your code is compiled. So we actually have things like over here, right, we have date, file, line, time. These are all predefined macros, right? We can type them into our program. And then these things, right, at compile time will be converted into maybe a string that contains that information, right? So if we want to, get the name of a file, right, when we compile it, right, maybe we want to print out, oh, this is file so-and-so.c, right, at line 500, whatever. We can actually get that information by using these two symbols here, the file and the line, right? Those two things will be ways for us to fetch information from the compilation process, right? Or maybe we want to know, we want to leave a timestamp that says, okay, this file was compiled at so-and-so time, right, on this date at this time. Well, then I can use those other two symbols there, right? I can use either date or time. And again, when we kind of in our program, right, we just type in these little names, right, and then once it gets compiled, right, once it gets fed through the preprocessor, those will be kind of naturally replaced with the information, right? It'll be naturally replaced with the actual date, with the actual time, right, or that actual file, or that actual line. So these can be kind of useful, right, when you're debugging stuff because it gives you a way to kind of say, oh, this thing went wrong here, right, this file, this line,